And the next one we have session management testing. This methodology involves testing the session management mechanism of the API. It aims to ensure that sessions are properly managed and terminated and that session data is protected from unauthorized access. So, session management testing is a crucial aspect of API testing that involves verifying the effectiveness of session management mechanisms in ensuring the security and privacy of user data during a session. This methodology is aimed at identifying any vulnerabilities in session management, such as the ability to hijack a session, and ensuring that proper security measures are in place to prevent unauthorized access to session data. To conduct session management testing, a tester needs to examine various aspects of the API, such as creation, session termination, session data storage, and session timeout. The following are some of the key areas that are typically tested during session management testing. First one, session creation. The tester needs to verify that a unique session ID is generated for each user session and it is not vulnerable to brute force attacks. Additionally, the tester needs to verify the session ID is not predictable or easily guessable. The next one is session termination. The tester needs to verify that the API terminates the session when the user logs out or after a predetermined period of inactivity. This is important to prevent session hijacking and unauthorized access to session data. Session data protection. The tester needs to verify that the session data is encrypted and protected from unauthorized access. This includes ensuring that sensitive information such as passwords and credit card details are not stored in clear text. Session timeout. The tester needs to verify that the API terminates the session after a predetermined period of inactivity to prevent unauthorized access to session data. In conclusion, session management testing is a crucial part of API testing that helps ensure the security and privacy of user data during a session. By testing session creation, termination, and data protection and timeout, testers can identify vulnerabilities in session management and implement appropriate security measures to protect sensitive user data. And after that, we have error handling testing. This methodology involves testing the error handling mechanism of the API. It aims to ensure that error messages do not reveal sensitive information, that they do not provide attackers with clue on how to exploit vulnerabilities. The main objective of this testing is to identify any vulnerabilities or weaknesses in the error handling mechanism that could be exploited by attackers to gain unauthorized access to sensitive data or system resources. During error handling testing, testers simulate various error scenarios to ensure that the API responds appropriately and returns accurate error messages. Tester may also attempt to input invalidated data and manipulate input values to trigger errors and test how the API handles this scenario. One important aspect of error handling testing is to ensure that error messages do not reveal any sensitive information that could be used by attackers to exploit vulnerabilities. For example, error messages should not contain details about the system architecture, user credential, or any other confidential information. Overall, error handling testing is an essential component of API testing and helps to ensure the security and reliability of the API. The next one we have API rate limiting testing. This methodology involves testing the rate limiting mechanism of the API. It aims to ensure that the API can handle a large volume of requests without compromising its performance and security. This process involves sending a large number of requests to the API and monitoring its behavior. The testing can be done manually or through the use of automated tools. Manual testing involves using a browser or a command line tools to send requests to the API and analyzing the response. Automated tools, on the other hand, can send a large number of requests to to the API in a short period and provide detailed reports on the API behavior. During rate limiting testing, the tester tries to exceed the rate limit set by the API and observe how it responds. The API should return a 429 status code indicating that the request rate has exceeded the limit. It should also include a retry after header that indicates that the client should wait before sending another request. The tester also checks for any security vulnerability that may arise from rate limiting. For example, a malicious user may attempt to bypass the rate limit by sending from multiple IP addresses or using a distributed denial of service, that is DDoS attack. The API should be able to detect and prevent such attacks. Overall, rate limiting testing is an essential part of API testing that helps ensure the API's reliability, performance, and security. And the next one we have API functionality testing. This methodology involves testing the functionality of the API. It aims to ensure that the API performs its intended function without any unintended side effects. It typically involves testing the input and output parameters of the API, checking for proper handling of error conditions, and verifying the API's behavior under different load and stress conditions. API functionality testing is an important part of the overall security testing projects, as it helps to ensure the quality and reliability of the API, which in turn can impact the quality and reliability of the application that use it. By testing the API functionality thoroughly, developers can identify and fix any issues or bugs before they cause problems for end users. The next one we have encryption testing. This methodology involves the testing of encryption mechanism of the API. It aims to ensure that sensitive data transmitted between the client and server is properly encrypted and cannot be intercepted by attackers. This methodology involves the examining of encryption mechanism used to protect sensitive data transmitted between the client and the server. The goal of encryption testing is to ensure that the data is properly encrypted in transit and at the rest, and that it cannot be intercepted or accessed by unauthorized parties. This involves testing the various encryption protocols and algorithms used by the API, as well as examining the strength and complexity of encryption keys. Additionally, encryption testing may also involve analyzing the configuration of SSL, TLS certificates and verifying that they are properly implemented and configured to provide secure communication between the client and server. Overall, encryption testing is a critical component of API security testing as it helps to ensure the confidentiality, integrity, and availability of sensitive transmitted data over the API. Denial of service testing. This methodology involves testing the API's ability to handle denial of service attacks. It aims to ensure that the API can continue to function even under heavy load or attack. DOS attacks are malicious attempts to disrupt the normal functioning of a system or network by flooding it with traffic or overloading it with requests. These attacks can cause the system to slow down, crash, or become unavailable, which can have serious consequences for the API users and the organizations that host it. DOS testing involves simulating a DOS attack on the API to see how it responds under heavy load or attack. The goal is to identify vulnerabilities in the API's architecture or implementation that could be exploited by the attacker. This testing can be done using various tools and techniques such as flood testing. This involves sending a large number of requests to the API to see how it handles the load. The goal is to identify any bottlenecks or performance issue that could be exploited by an attacker. Slow loris testing. This involves sending a large number of requests to the API but slowly and gradually to see how it handles slow connections. The goal is to identify any vulnerabilities in the API connections handling mechanism that could be exploited by an attacker. Application layer DOS testing. This involves sending requests that exploit vulnerabilities in the API's application layer, such as buffer overflow or SQL injection. The goal is to identify any vulnerabilities in the API's implementation that could be exploited by an attacker. Overall, DOS testing is an essential part of security that helps ensure that the API can continue to function even under heavy load or attack. By identifying and addressing vulnerabilities before they can be exploited by attackers, organizations can help protect their users and maintain the integrity of their systems. Overall, a comprehensive API security testing should cover all aspects of API security, including authentication, input validation, session management, error handling, rate limiting, functionality, encryption, and DOS protections. Rather than that, we have more. Parameter tampering testing. This methodology involves testing whether the API is vulnerable to parameter tampering attacks. It aims to ensure that the API can detect and prevent unauthorized changes to input parameters. Parameter tampering testing is a security testing technique that focuses on identifying vulnerabilities in API that could allow an attacker to manipulate input parameters and cause the system to behave in unexpected ways. In this testing methodology, testers attempt to modify input parameters in various ways, such as changing their values, adding or removing parameters, and testing for different combination of parameters. The goal is to verify that the API is properly validating input parameters, detecting any tampering attempts, and responding appropriately by rejecting unauthorized changes or providing suitable error messages. By conducting parameter tampering testing, organizations can ensure that their APIs are robust and secure against common attack vectors, reducing the risk of data breaches, system failures, and other security incidents. The next one is API first testing. This methodology involves testing the API for unexpected behavior when it receives invalid or man-unfound data. It aims to ensure that the API can handle unexpected data gracefully without crashing or exposing sensitive information. The main goal of API first testing is to ensure that the API can handle unexpected and invalid data. This testing method is especially useful in finding vulnerabilities related to buffer overflow, injection attacks, and other type of security issues. API first testing can be done manually or using automated tools specifically designed for the purpose. Some popular API first testing tools include OWASP Zap, Fuzz API, and RESTLM. Overall, API first testing is an important part of the software testing process and helps to ensure that APIs are secure, reliable, and function as intended. The next one we have API versioning testing. This methodology involves testing the backward compatibility of the API with different versions. It aims to ensure that changes to the API do not break existing the client application and that new versions of the API are properly secured. This type-of is particularly important when changes are made to the API, as it ensures that the changes do not negatively impact existing client applications that rely on the API. By testing for backward compatibility, tester can ensure that older versions of API can still function properly with newer versions, and that the client application built with older versions of the API are not broken by updates to the API. Additionally, versioning testing can help ensure that the new versions of the API are properly secured, as security is a critical concern when working with API. The next one we have API schema validation testing. This methodology involves testing the validity and consistency of the API schema, including data types, field names, and corresponding data. It aims to ensure that the API schema is properly defined and adheres to industry standards. API schema validation testing typically involves checking the syntax and semantics of the API schema, verifying the data types, field names, and their corresponding data, and ensuring that the API responses are consistent and valid. This type of testing is critical to ensure that the API is functioning as expected and can be used by other applications or services without any issues. By performing API schema validation testing, developers can catch potential issues early on in the development cycle, which can save time and effort in the long run. It can also help to prevent errors and inconsistency in the API, which could lead to data loss, security breaches, or other serious problems. The next one we have API performance testing. This methodology involves testing the API performance under different load conditions. It aims to ensure that the API can handle a large number of requests and respond within acceptable time limits. The main goal of API performance testing is to identify any performance bottleneck and then ensure that the API meets its performance requirements before it is deployed to production. This type of testing is critical in ensuring that the APIs are reliable, responsive, and able to handle the load that they are expected to receive. And after that, we have API security standards compliance testing. This method involves testing whether the API adheres to established security standard and best practices, such as OWASP API Security Top 10, NIST, that is NIST Cyber Security Framework, and ISO IES 27001. API security standards compliance testing is a process that involves testing whether an API adheres to established security standard and practices. The goal of this testing is to identify any security vulnerabilities in the API and ensure that it meets the security requirements of the organization or industry standards. The methodology for API security standards compliance testing typically involves the following steps. First one, identifying the security standard and the best practices that are applicable to the API. This may include standards such as OAuth API Topic 610, NIST Cyber Security Framework, and ISO IS 27001. Conducting a security audit of the API to assess its compliance with the identified security standard and best practices. This may involve reviewing the API architecture, design, implementation, and documentation. Performing penetration testing to identify any vulnerabilities in the API security controls. This may involve attempting to exploit weaknesses in the API authentication, authorization, input validation, and output encoding mechanism. Analyzing the result of the security audit and penetration testing to identify any gaps in the API security posture. Developing a remediation plan to address any security vulnerability or gaps identified in the testing process. Retesting the API after implementing the remediation plan to ensure that it meets the identified security standards and best practices. Overall, API security standards compliance testing is an important process for ensuring the security of APIs and the data they manage by adhering to established security standards and best practices. Organization can reduce the risk of data breaches, unauthorized access, and other security incidents that could result in significant financial and reputational damage. And the next one we have API access control testing. This methodology involves testing whether the API provides secure access control mechanism such as API keys, OAuth tokens, and role-based access control. It aims to ensure that access to the API is granted before based on the principle of least privileges. API keys are typically a unique identifier used by the API provider to authenticate and authorize API requests. OAuth tokens are another type of authorization mechanism commonly used to grant temporary access to APIs. Role-based access control is a security model that restricts access based on the roles and permission assigned to users or groups. The primary goal of API access control testing is to verify that access to the API is granted based on the principle of least privileges. This means that the user or application should only be given access to the resources and functionality that are necessary for them to perform their tasks. The testing process involves verifying that the API is designed to restrict access to resources based on the roles and permission assigned to the user or application making the request. This may include testing for specific scenarios such as unauthorized access attempts, incorrect or missing authentication credentials, and excessive permissions granted to users or application. In summary, API access control is a crucial step in ensuring that the API is secure and that can be access to sensitive information and functionality is controlled and restricted appropriately. By testing the API for secure access control mechanism such as API keys, OAuth tokens, and RBAC, organization can help ensure that the API are designed with security in mind and can prevent unauthorized access to their data and system.